All right, you guys have about 8 minutes to work through these. Also, if you're looking for what sections are on this exam, I added it to the recommended book problems document on Canvas. So you can find that as well as which mechanisms are fair game for the exam. So take a look at that when you have a minute.
Oh my goodness. Now we're freaking out about this, Aaron.
Hold up. We're not
All right, let's get started on these. So this first one is basically our simplest reaction. So our carbonyl is going to attack this proton, and then our water can come in to displace. We're going to end up with diols. Both where that carbonyl was. Our next one is slightly more complicated. So we got ethanol here. We're going to end up doing a similar reaction, except we're going to displace water, have another ethanol come in. So we're going to make an acetal out of this. For this one here, we've got a secondary amine. Which means we first have to make our imine would look something like this here. We have two different beta positions. One of them is tertiary, one of them secondary. This is a large base, so it's going to favor the secondary position. We're going to end up with our enamine, where a double bond is on the left side here. Giving us this product. All right, we've got a diol here. We've got 1, 2, 3, 4, 5 atoms on it. We're gonna get another one from the carbonyl position. So we're gonna end up with a 6-membered ring out of this. Should look something like this here. You can also count the carbons in between. So we have 1, 2, 3 carbons, 1, 2, 3. That's how you know you're gonna get the size of your ring from that, if it's correct or not. All right, this one is primary. This makes it a little easier. We're just gonna replace this nitrogen with the oxygen, or oxygen with the nitrogen. To get our imine product. Our next two, we have a hydrazone and an oxime here. They both are going to have nitrogen act as their nucleophile. We're just going to ignore the other substituent. So for this one, we'll just use one of our 2 nitrogens. We'll get another imine. With the other NH2 attached to it. We have an NH2 and an OH. Our nitrogen is going to be our better nucleophile. So we're basically doing the same thing as we did up there. We're going to have an imine with that OH coming off of it. Last one is the same thing as this reaction, except with sulfurs. We have 1 less carbon, so we should make a 5-membered ring in this case. Giving us this product. All right, so that's a bit of a review of what we talked about on Wednesday. Today, I'm going to go through 2 more reactions, and then that'll be the end of the material for this exam. We're going to do some synthesis problems after that, and that should be pretty much the whole day. So our first reaction is, it's really the opposite of a nose analysis. So if you remember back, maybe chapter 8, we did this reaction. We throw in O3, DMS. We're able to break our double bond. We get 2 oxygens. Both of them being aldehydes in this case. Today, we're going to do a reaction that's called the Wittig reaction. It's going to be 19.10. And what we're going to be doing is we're going to be taking essentially two halves like this and stitching them together. One half will be in either an ketone or an aldehyde. The other half is going to be what's called a ylide, which is going to be, it looks like a carbonyl, but instead it has triphenylphosphine on it. When we do this reaction, we're going to end up having the two double bonds come together. We had a methyl group coming off of here. We had 1, 2, 3 carbons coming off the other side. We've essentially stitched these two halves together. And we're also going to end up with a byproduct, which is triphenylphosphine. Oxide, triphenylphosphine oxide. All right, so the way this reaction happens is we're going to start off with a alkyl halide. So if you're taking something like propyl bromide here, plus PPH3, which is triphenylphosphine. We're going to do an SN2. So our triphenylphosphine is going to come and attack, pick out Br. And then we're going to throw in a really strong base to pull off this proton here and give us what's called a ylide. So if we take N-butyllithium, which is really just 4 carbons with a negative charge on it, and grab this H. And we are going to make, referred to as a ylide here. You guys may have done this in lab at this point. Okay, so from here, this has 2 different resonance structures. You can either have this or push these electrons up. To this one here. And this is the one we're going to be using for our actual reaction. So if we put this in solution with a carbonyl, so let's take this cyclohexanone here. Our negative charge is going to attack our carbonyl. And then our double bond from our carbonyl is going to attack this triphenylphosphine here. We're going to make a 4-membered ring. That looks like this. I think this is working. We are going to kick electrons down to form the double bond, kick these ones up to form our triphenylphosphine oxide. This is going to give us our product. Carbons? I think that's too many carbons. Plus PPH3O. And I'm going to talk through one more of these, and then we're going to move on to the other reaction. All right, so take this substituted cyclohexanone, throw it in with this yellow here. If we add these two together, we're going to break this bond here, break this here. We'll end up stitching our two. Double bonds into an alkene. So then now we need the one carbon as well as this. Oops, that's a 6 member ring. Whatever. Oh man. To get the 5-member ring product here. And if you think about this, if you throw in O3 DMS, you can almost get the exact same product back. So you're going to break your double bond here. You'll get the same thing back for this half of it. The other half up here is going to end up with an oxygen instead of a triphenylphosphine, but overall, same concept. When you don't need to write triphenylphosphine oxide is one of the products here. No one's doing this reaction to get that, so don't worry about that part of it. All right, our last reaction is called the Baeyer-Villiger reaction. Or Baeyer-Villiger oxidation, actually. So what this is we're going to take a ketone or an aldehyde. We're going to throw an MCPBA. And we're going to oxidize this to either a carboxylic acid or an ester. We're not going to do a mechanism for this one because it's kind of odd and I don't like doing these kind of mechanisms. All right, so for the selectivity of these, your highest priority group is actually going to be a proton, which means if we have an aldehyde, this will just oxidize to a carboxylic acid. Next is going to be tertiary, followed by either secondary or phenyl, which means it's attached to an aromatic ring, followed by primary. So let's do a few of these. If I have this here, I've got an H versus a secondary center. So looking at my little chart here, H is the higher priority, which means that's the side that's going to get the oxygen to it. So this is going to give us a carboxylic acid. If we have a tertiary and a primary, tertiary is going to be favored. So that's the side the oxygen is going to get inserted into. and we can end up with this product. All right, lastly, let's do an aromatic one. So now we have phenyl on one side, primary on the other. So phenyl's gonna be our higher priority group. We're gonna insert our oxygen between the phenyl and the carbonyl here. And we'll get an ester where our oxygen is attached to our ring. Someone asked if you had excess, would it add to both sides? I don't think this actually works with carboxylic acids, so, or esters. So if you added more MCPBA, oh god, MCPBA here, you're gonna end up getting no reaction. It won't just keep oxidizing forever. So all right, so this shows you how to make this functional group, which we ended up using as one of our, it's group 2 from our table. So we're going to end up using that in synthesis problems. And I'm going to go through a couple of reactions that kind of incorporate both chapter 18 and 19 synthesis problems. But I'm going to start off by doing one that's just chapter 19. So that's the end of the material that'll be covered on this exam. I'm going to start doing some synthesis problems to kind of help you guys get ready for it. So let's start off with something that looks like this here. So taking a look at this, the first thing I notice is that we're doing a lot of chemistry on this side of our molecule, and we're doing absolutely nothing with this ketone here, which is a hint that we might need a protecting group. We also got to add a carbon over here, which means we're probably doing a Grignard. If we do a Grignard with a free ketone in solution, it's going to attack that. So that's also another solution. So our easiest way to protect these ketones would be to throw in some sort of diol. I'm going to do the 5-membered ring one. You can do the 6-membered ring one. It doesn't really matter. I wouldn't do a 4 or a 7 just because they're a lot less stable. So they are selective for aldehydes and ketones. They do not react with carboxylic acids or esters. We're able to add this protecting group. Oh, that's a little rough. All right. From here, we want to probably alkylate. If we throw in methyl Grignard with an ester, it's going to dialkylate. So we're going to want to reduce this first. Throwing in LAH and the water. Can give us an alcohol, which we can oxidize. Do our Grignard. Yeah, we're in a methyl group to it. we've got the majority of what we want from a molecule. We want to add just a ethyl group here, so throwing in some sort of a base. Throw an NaH and ethyl iodide. Gets us to the protected version of this, and we can throw an H plus and H2O, which will remove this protecting group here. So you're doing a lot of the reactions you guys have already done. You're just throwing in a way to protect aldehydes and ketones as opposed to alcohols, which we already knew about. I'm gonna give you guys a little bit of time to write all that down. All right, so let's do one that's both 18 and 19. Starting with an aromatic ring. And we can add both a alkyl group and this alcohol with a nitrile on it. So taking a look at this, we got two different groups. Got this guy and we got this guy. We're probably adding them separate. If I try to analyze where I think they came from, this one's probably pretty straightforward. It's going to be something like this. This might have been a acyl group, and then we came in with the nitrate. So that might be kind of our two-step way to get there. All right, there's really two different ways you could do this. I'm going to do the way where we add the alkyl group first. So if I add my alkyl group, this here, I've got an ortho para director. This thing's pretty big. It's probably going to add para. So then I could have this second group over here. And then from this point, I just need to add my nitrile so I could throw in KCN in HCN. And we could add that, have that attack our carbonyl and protonate. So the other way you could do this, if I can draw this down at the bottom here. So you could do the opposite reaction. So if I take my benzene ring and throw in my acyl group first, oops. At this point here, I can't do anything. This is a meta director, so I don't want to add my alkyl group yet. But if I do my alkylation for my adding the nitrile, so KCN, HCN, This is now just a carbon group here. Doesn't really have any sort of, nothing's donating into our ring. So it's not gonna be a meta director. This is still gonna be an ortho para director, which means at this point, if we wanted to add in our just our alkyl group here, this is gonna be selective for just that para position and also give us our product. So as long as you don't do the alkylation at this step here, it'll work either way you do it. All right, I'm gonna throw up some example synthesis problems, have you guys work through them. And, oh wait, do I have one more? Oh no, never mind. Yes, okay, I'm gonna throw up the sample synthesis problems, have you guys work through them, and then we'll talk about them together. Oh, I did the same, god damn it. This should start from benzene, I just drew it backwards. All right, as a hint, this one can be done in 2 steps. So I'm gonna give you guys about, probably about 5 minutes. We'll talk through this one. I'll give you another 5 minutes if we talk through this one. We'll do the last one on Monday. All right, for this first one here, you throw an MCPVA. You're going to be able to insert an oxygen. We got two different positions. We got a tertiary and a primary. It's going to go between the tertiary one, or tertiary and secondary, sorry. And then from here, all you need to do is throw in propyl Grignard. And you're able to dialkylate to your final product. Microshovel. I'll leave this up for a second, then I'll throw the other back up there. All right, so take about 5 minutes, and I'm gonna let you guys work through this second one, and then we'll go through that one together. What about the isopropyl? Yeah, you technically, your byproduct would be plus OH. Your Grignard would come in, do an attack. You're gonna kick out this isopropyl, make the single substituted, and then another Grignard will come in, kick out that other one. You're just doing a Grignard with an ester. All right. All right, I'm gonna go through this second one and then we'll do the last one on Monday. So there's a couple different ways you can do this one. I'm gonna start with the bromination first. If I kind of break this down, I've got 3 components I gotta add. I gotta add a BR, a CL, and I'm gonna do this as a VIDIG. There's another way you could do it, but that's gonna be the most straightforward way to do it. So let's add the BR first. So BR2, FEBR3. This is an ortho-para director. If I add this large group here, it's gonna most likely go para. I'm gonna add it as an acyl chloride and then do the VIDIG later. So adding this as an acyl group here would get me to this. From this point, you have a couple options. You could either do the VIDIG now, you could chlorinate now. I'm gonna chlorinate now. We've got a 4 versus a 5. This is an ortho-para director. The para is blocked, so we can add to one of these 2 orthos. So I add in my CL2, AlCl3. I can chlorinate, and then from there, I just need to add in my triphenylphosphine, yield it here to get my final product. There are a couple of different ways. Yeah, so someone in the chat asked if you could add the acyl chloride first. So if you add the acyl chloride first, you're going to acylate, that'll be a meta director. So you could add your chlorine, which would then be an ortho-para director. The most likely position the BR would go to would be here. So that also works. I think the only thing that's going to be a real pain is if you add the chlorine first, because then you're going to end up with both CL and BR on there. Yeah, the only one that's going to actually be problematic is if you chlorinate and then brominate, and then there's not going to be discernible. This can go, the next step could go to any of these positions here. Someone asked, I understand we want the Wittig here, but we ought to chlorinate the alkyl group as a whole on. I think you mean, could you also do, whoops, don't want that. If you were to just alkylate, and then try to do something like NBS to add a bromine here. The problem is you're never going to be able to force the double bond to be here and not to here. So you'll always end up with 2 products from that one, as opposed to if you do the VIDIG, you're only going to get the 1 product. So it's a little bit more selective in that case. But I mean, this still would be worth the majority of the points. So, okay, wait, what is today? Friday. On Monday, we are going to go over the practice exams, and then on Wednesday, we're going to have our next exam. So I will see you guys then. So someone asked if I can, Mr. Long, yeah, do an announcement with the sections covered on the exam. If you go to the practice problem worksheet, like the document that's under practice problems, it gives you all the book problems. I listed all the mechanisms that are to be on this exam, as well as the chapters or sections. So take a look at that book problems document. The practice exam should already be uploaded. I'll double check to make sure they are. Thought they were in these.